The first of those navigation options I'm going to look at is navigation references. Navigating to an entity reference, to a single entity, is relatively straightforward. So here's a query that retrieves all sales order header entities with an order date in 2004, right there, so that's the predicate and the where method, and projects the results into an anonymous type with an order and customer property. So here I'm retrieving the entire set of orders and retrieving the customer object. So as you can see from the pop-up, AWLT customer, and this is, if it pops up, well, it's not showing the, okay, well, this is going to be a sales order header object. Okay. So I'll go ahead and execute this query. And there you can see that the query results in an anonymous type. Again, I don't have a type right there. It's a DB query, so that's the query. And it has order and customer properties. And so the order consists of a sales order header object, and the customer consists of a customer object. Let's see if I can hover over it now. No, still doesn't show it. Okay, well, it is a sales order header object. Okay, so all I needed to do was use this customer property to get a navigation reference to the customer associated with each of these orders. And that's why I have specific information, because Catherine Abel placed this order back on June 1st, 2004. Okay, now if I were to use this query in code, I would use this navigation query ref with entities, and I'll go to the definition. And there's that same link expression, order date year 2004, and I'm projecting out the results, order and customer. But once again, in order to get access to the properties, I need to use this order object in that orders collection that I'm getting back and reference the order property to get information about the orders, and then use the customer property in order to get information about the customer. And so when I execute this query, there are the results. And so you can see some order information, the order number and the date, PO information, and then the company name and the contact. So these are coming from two different tables within the AdventureWorks LT database, but I've combined them together into an anonymous type that has an order and customer property. All right, you can also use this technique in order to project individual properties from referenced entities. So here's another query, same sort of thing. It's once again getting the orders from 2004. But this time it's also filtering on the company name so that I only retrieve companies that start with C. And then it sorts the results by company name. All right, then the query returns an anonymous type that consists of various properties of the order and customer. So here I have a new anonymous type, I'm not even naming it, and I'm outputting the order date, the sales order number, account number, ship method, and the company name, as well as a contact property that is a concatenation of the first and last names of the customer. So this time the anonymous type doesn't include the complete order or customer entities, just the specific properties that I list here within the select method. All right, so I can run this query. And you'll see now I have a single table. I don't have individual properties for different parts of it, and I have an anonymous type, and the anonymous type has order date, sales order number, account number, ship method, company name, contact, properties. And as you can see, the contact property is a single property. It's a string, and it's a concatenated name together of the first and last name. Okay, so now how you use this query in code is a little bit different as well. Rather than referencing a property, you instead, actually let me go up and change my method selection here. Okay, so there's that same query, it's just using properties. But now what I need to do is reference the different properties of this order object. So I have order date, and so I need to do order date, and here I'm converting it to a short date string, and then reading the various other properties of the different objects. And just keep in mind that contact is not an object. Well, string is an object, but it's not a complex object. It's just a string. Okay, so now when I execute this code, same basic results, but it's just accessing the data differently because I'm projecting the data in a different format. All right, so that shows how easy it is to use navigation references. So let's talk about navigation collections. In simple queries, querying a navigation collection isn't all that different from querying a navigation reference. The main difference is that the resulting anonymous type has a property that is a collection rather than a single entity or scalar property values. For example, here's a query that returns a collection of those customers that have placed at least one sales order. The results project the entire customer object, so I'm returning that under the client property, and I'm returning that entire customer object. Again, I know that's the customer object because that's the control variable, and the type of objects within this collection are customer objects. Okay, so that's easy enough. Each of these objects is going to have a single customer object. And then it has a collection of objects in the orders property that consists of all the sales order headers, sales orders, for that particular customer. So this is a collection. It's more than one. It's not the scalar properties in the last couple code examples that I was showing you. Okay, so I can execute this here. And I have some very big results. So here's the customer information. So this is for Catherine Abel. And then she has placed this collection of sales order headers. She only placed one, but if there was more than one, they would be listed here. Yet another of the quirks of the AdventureWorks LT database is that there's only ever one order per customer. A real-life database, of course, would have at least some customers with multiple orders, unless the company is really doing a poor job of serving its customers. Okay, so let's look at this in the sample application. Once again, go in, up, and change my method. And then go to the definition. All right, so here is that same link expression. And then once again, because this is a collection here, I can reference the properties of the client directly off that customer object, but then I need to use that orders property in order to access the members of the collection in a nested for each loop. And then using that order object, I can then access the different properties that I want to display from each of those orders. All right, so I'll go ahead and execute that. And there you can see that Eastside Department Stores, the contact name is Kevin Liu, placed an order on June 1st, 2004 at 12 o'clock, but it's actually not a valid time. It's midnight, with a PO number and an amount due. Okay? So that shows how you can process those kinds of results when you have a collection that is returned as a property of each of the objects. Okay, so again, it's returning an anonymous object. It has a client property that has a awlt.customer order or customer type, and then it has an orders that is a collection of sales order headers. So anonymous type, but it contains a couple properties that use actual objects that are created within the entity framework through the data model. And then you can take it one step further. Coming back over here to LinkPad. You can also retrieve only a subset of the properties in the collection objects rather than the entire sales order header entity. So this is essentially a variation on other examples that I've shown you, but it's taking it down a notch because the collection is not the overall collection that the link expression is returning, but it's a collection that is a property of each of the objects. Okay, so here's a query that does exactly that. So we have c.company name, not returning the entire customer, just returning the company name. Once again, creating a contact that is a concatenated first and last name. And then it's processing the sales order headers, but it's projecting the results, not returning the entire sales order header object for each item in the collection, but creating an anonymous type that is just displaying the order date, the sales order number, and the total due. And in a couple of cases, giving them different names. So here, I'm getting an anonymous type for each object in this collection that passes muster of the filter. And then the order's property consists of yet another anonymous type that has a subset of the data from the sales order headers, a subset of the fields or columns, as the properties of that anonymous type. So it's a nested anonymous type. All right, so I can execute this query. And there we go. There's the company name, the contact, and then a collection of the orders. Again, there's only ever one per customer, but if there were more, they would be listed here. And then it has an anonymous object, again, an anonymous type there, as it is here, that has an ordered sales order number and total properties. And again, total and ordered are not properties or fields within that table, but I define them here within the projection. All right, now, you can use related data for filtering and sorting, but with collections, you need to use operations that apply to collections instead of single entities. So here's an example of that. So what's happening here is that it returns all customers who placed orders in 2004 by filtering on the s.orderdate.year and using the any method to return any customers that had orders in 2004. Okay, so that's maybe a little bit confusing. Again, the context here is that we're using the customer's collection here, so I'm going to get back customer objects. But I want to filter them. I'm going to get customer objects back. I'm not projecting. I'm not getting anonymous types. I'm actually getting customer types. But I want to filter them on data that's contained within a collection within that each customer object, the collection of sales order headers, which is the navigation collection property that's defined within the entity data model. So I use this lambda expression referencing the C item here, which is going to be the customer. It's going to reference the sales order headers. And then instead of using where here, I'm using any, so that I'm going to return all of the customers, any of the customers, who placed an order in 2004. So hopefully that makes sense. Very powerful technique, but if you don't have your head around it, it can be kind of confusing. And so there we have a list of all those customers, and these are customer objects. It's not an anonymous type. So it's a customer object, and it returns all of the customer fields. Doesn't return any of the sales order fields, except that because this is a customer object, the sales order headers collection comes along as part of the object. And within LinkPad, I can click on that, and it will display the collection of sales order headers. So hopefully you're starting to see just how powerful and flexible this is to get at the data. And it's actually kind of amazing that very often the code that you need to write is quite a bit simpler than the SQL code. In fact, you can look at it here, and there's the SQL expression for that fairly complex SQL statement for this relatively simple link expression. Now you probably have to think a bit about how to implement this based on the kind of data that you have, but it's very straightforward once you understand the syntax and how link executes the code in order to generate the select statement, the SQL select statement, to retrieve the data from the database.